So today we're going to be working with composite functions, which we've really worked with before, but now we're just going to explicitly define them. So we're going to be working with the composite of f and g. And the composite of f and g is written as f circle g, so it looks like the word fog, but it's red f circle g. And what it means is you're evaluating the f function at the g function. And sometimes f circle g, just like we did before with the addition and subtraction and multiplication, can be written as f circle g of x. It means the exact same thing, just two different ways of writing it. And this is stuff that we've done before in the past. We did it in 1-2. We did it in the last lesson that we did before we went on our Thanksgiving weekend. So examples. Given f of x is the function 6 minus 3x, and g of x is the function negative 2x squared plus 4. We're just going to determine some composite functions. But before we get into determining composite functions, let's just review function notation and evaluating functions at different values. So, and again, we've done a lot of this, but if somebody explain to me what that means and how do I get to the answer? Maybe we haven't done enough of this. Sure.
And we just, wherever you see exercise 2, make it 1.
Right. Okay, so again, I'm using the f function. How do I know I'm using the f function? Because that's what it tells me. This is what I'm replacing my independent variable for. My independent variable is my x. So this means use the f function, but everywhere you see an x, replace it with the number inside of the bracket. Right? And we've done a lot of this. Right? So then simplifying this, negative 3 times negative 1 is positive 3, add 6 is 9. Any questions on that? And I can evaluate a function at any single value or any single expression. So I ask f at a. The concept's exactly the same. Okay, so I'm going to do the exact same thing. I'm going to take a, substitute it into the f function everywhere I see an x. If I can simplify, I simplify. If I can't, I'm done. I can take whatever I want and whichever function I want and substitute anything I want inside of that function. So in this case, I'm going to use the g function, and I'm going to substitute a plus 1 into the g function. So everywhere I see an x in the g function, I replace it with a plus 1. Now it's just a matter of simplifying. And again, simplify properly. I'm still getting a lot of people, surprisingly, writing this a plus 1 squared as a squared plus 1, forgetting that whole middle term. And that's happening quite a bit. Also, I'm getting people multiplying this negative 2 inside of the bracket before you even square it. Okay, so remember BEDMAS, remember to expand out your brackets. So this would be negative 2 a squared plus 2a plus 1 plus 4. Distribute the negative 2 through the bracket. Negative 2 and 1 make negative 2. Add it to 4, be plus 2. Yeah. Sorry, but then I added it to the 4th. Yeah, I skipped a step. Okay. Any questions on that? Okay, so I can take whatever I want and I could substitute it into the function. So now we're going to get into some composite functions. So F circle G. F circle G means, so every time you see that, rewrite it into what it means. So it means F evaluated at G of X. So whenever you're working with composite functions, you're going to work with the inside function and then work your way out. Okay, so the first thing you're going to replace is what G of X is equal to. So by definition, G of X is equal to negative 2x squared plus 4. So I'm just taking this and replacing it in here. So it becomes F at negative 2x squared plus 4. Does that make sense? I'm just replacing what G of X is equal to, because it told me what it was in the question. Then what do I do? Right, everywhere you see an X, right? So I'm taking what's inside of the bracket and I'm putting it into the F function. Everywhere I see an X, I'm replacing it with X. So it becomes, the F function is 6 minus 3, but instead of writing X, I'm writing down what's in the bracket. And once I've done that, I'm going to simplify. Selecting like terms, I'm putting it in standard form. As long as I did that correctly, that would be mine. Any questions on that? Okay. So G circle. So a lot of times we're saying in mathematics, the order sometimes doesn't matter. Like if I take F and times it by G, I'll get the same answer if I take G and times it by F. Not true with composite functions. This is an entirely different question. Because G circle F means G evaluated at the F function. So the first thing, you always work the inside first. I'm going to replace what f of x is equal to. And by definition, f of x was 6 minus 3x. And then it becomes a question just like the other ones. The concept's the same. I'm taking what's inside of the bracket, looking at the g function, which is this right here, and replacing what's inside of the bracket into the x. It becomes negative 2, bracket 6 minus 3x squared. Make sense? Now it's just a matter of expanding and simplifying. And again, if you're still struggling with your algebra, just take that extra time and write out the question. Okay, if you're able to go right to the answer, you can do that. So 6 squared is 36. 18 doubled is 36. And then plus 9x squared. So when I multiply out the bracket, I get that. Negative 72, positive 72, negative 18, plus 4, so put it in standard form. And you never have to factor your answer unless the question said put it in factored form. Otherwise, just leave it in standard form. So that is G circle, as long as I did all my algebra correctly. Nobody's saying otherwise, that looks pretty good. Okay. Did I screw up? No, good. Okay. And I could take a composition of a function with itself. F circle F means, actually let's just put in, so you get used to that notation as well. It means the exact same thing, just so you're used to it. So F circle F at X means F evaluated at F at X. So you're starting out always with the inside and you're replacing it. So F evaluated at F of X by definition is 6 minus 3X. And then you're taking what's inside of the bracket, substituting it into the f function everywhere you see an x. So it becomes 6 minus 3, but instead of writing x, you're writing down what's inside of the bracket. Simplifying. Writing it in standard form, I get 9x. Does that make sense for composite functions? So you're just taking a function and you're substituting it into another function. We've done it before. We did it in 1, 2, and we did it in the last lesson. Okay, but now we're just explicitly talking about it. Okay, so it becomes a little bit harder for people when you're working with discrete functions. So given, but the concept is exactly the same, and actually it's a little bit easier once you get the hang of it. It's a lot less work. So given the discrete function, remember that a discrete function, bless you, is a set of points. So these are the 4 points that make up the f function. And the g function is defined by these set of points. Okay, we have all that. I'd like to determine the following. So how do I figure out what g at 1 is, just given that information? Anybody? Right, which in this case is 6. Okay, so this tells you what function you're using, this tells you what value you're looking for, and this is the answer. Make sense? Okay, so then f at g at negative. So this is about asking you to figure out what f of g at negative 1 is. So always with composite functions, right, you start with the inside. So you figure out what g at negative 1 is, get that answer, replace it, and then figure out what f of what that answer is. So f at g at negative 1, what's g at negative 1? Yep, 0. And what's f at 0? Rebecca. Anybody have no clue where Rebecca got these answers from? You're just reading them off the points, right? So when x is this, you're looking for what y is, right? So g, negative 1, g, here's negative 1, that's 0, so I replace it. Then I look for f at 0, here's f, here's 0, the answer's 3. Make sense? Okay. Becomes a little bit harder now when you're trying to come up with a function that defines the composite function. Oops, that should be a C. F circle G. But the concept and everything's the same, and I'm going to show you how to do it the long way, and then eventually you'll be able to hopefully do it the quick way without having to write down any of the work. So F circle G means F evaluated at G of X. So you always, with a composite function, start with the inside function. So with a composite discrete function, you're going to start with the domain of the inside function. Start with domain, and that's important, of inside function. So the domain is just a fancy word for saying the x values. So use all the x values of the inside function. So I'm going to write my answer here. It's going to be a set of points. Okay, I'm going to do my rough work down here. The stuff that I do in my rough work, I don't need to see on the test. If some of you will be able to do it without doing the rough work, okay? Some of you will be able to write the answer right off the bat, and that's fine. Okay, So I'm figuring out f at g of x. I need to start with I have to use all these x values of the g function. Okay, so I'm going to start with -3, because that's the first one. So I need to figure out f at g at -3. So g at -3 is -1. F at -1 is 2. So I started with -3, and I ended up with 2, so that's my first point on my function. So I've used that, now I go to the next x value. And again, I'm starting with the g function. That's the most important thing. You start with the inside function, not the outside function. So now I have to do it for -1. So f of g at -1. G at -1 is 0. F at 0 is 3. So I started with -1, and I got 3 as an answer. Move on to the next one. F at g at 0. G at 0 is -3. Go up. Where is f equal to -3? It's Kyle. You see a -3 up there anywhere in the x position? Yeah, but that's why. Yes, you were looking at the x. So do you see one? So you can't do it. Okay? So it does not exist. If you don't get an answer for that one, do the next one. F at g, and I'm just doing them in order. So I did 0, now I'm on to 1. G at 1 is equal to 6. I look up. What is f equal to when x is 6? There isn't one, so again, does not exist. I can't do. I'm just writing d and e, just short form does not exist. Can't do it. So there's no point for that one. Now I'll do the last one, which is 2. G at 2 is 2, and f at 2 is -3. So I got a point. I started with 2, and I ended with -3. So let's try, I'll have you guys try this one. G at f. So try it yourself. I'm just going to pause this so that you're watching it and not just sitting there. So again, G circle f means G evaluated at f at x. So I'm going to list my answer here. And again, once you get the hang of it, you won't need to do all the side work here, but you're starting with the f function. You're starting with the x values of the f function. So it would be g evaluated at f at -1, because that's my first x value. F at -1 is 2. G at 2 is 2. So my first point is -1 and 2. Then I move to my next value, which is 0. F at 0 is 3. G at 3, there isn't one, so I can't do it. Does not exist. Then my next x value, which is 1. F at 1 is 4. G at 4, there isn't one, so I can't do it. Then my last x value in my f function is 2. G at -2 is -3. And G at -3 is -3. So I started with 2 and ended up with -1. That would be my G circle f. A question? So again, if you get the hang of it, right, you don't have to write down that stuff in red, right? So if I was doing this on a test, what I would say is, okay, I'm starting with the f function. I'm starting with always my first value. -1 became 2. I look for here. 2 becomes 2. I got -1 and 2. 0 becomes 3. There's no 3, can't do it. 1 becomes 4. There's no 4, can't do it. 2 becomes -3. -3 becomes -1. And I would just write down 2 and -1. Instead of doing all that extra work, I was just showing you how I was getting the extra work. Any questions? Okay. So I will save this, and then I'll call up the people who wrote.